I wanted to put this video together for the purpose of discussing and exploring dividing space in perspective, mainly in 2-point and 3-point. These three squares at the bottom left are going to be used as a standard, using these geometric solutions to find the divisions. First on the left being 3 even spaces, the middle one being 4 equal spaces, and the last one being 5. I first built the even divisions by using software to divide the widths of the squares evenly, and then check them with these diagonal lines, which are commonly seen in perspective drawing. In all cases, all of the intersecting lines snap, or in other words, each vertex or node that intersects is on the same coordinate. So knowing that these diagonal lines give us the divisions we're looking for, we can then test other methods in perspective against these diagonals. This is a basic 2-point perspective grid with the vanishing points equally far apart, resulting in a 45-degree square. The first geometric grid is a division in thirds for the square, and now we can test other popular methods commonly used in perspective against it. This is the first. I'll just call it corn rows because that's what it looks like to me, and we can check it against the thirds. For all of these tests, all of these lines, I've placed them going from the vanishing point to the picture plane, and from the picture plane going to the vanishing point, checking them at every intersection pointing in each direction. So for example, at this intersection I would check that it would snap, making sure the coordinates are the same, and then I would extend the line from that point rather than taking it to this point and letting it snap here. I would see if it would snap at every location, including the final intersection. And that's going in both directions, and that's for every one of these grids going forward. So by placing this line parallel to the horizon line, you can take measurements across it horizontally and back to the left vanishing point. If this were the right vanishing point, it would be on the left side of the square. This is useful, but it can be a little harder to use on traditional media, since the space that's given here to be divided is going to be dictated by these converging lines. It can get more complicated the higher the number of divisions, but testing it here against these diagonals, it does line up. Same test here. This is just quarters or evenly spaced divisions. Everything else is the same. We move on to fifths, and these line up as well. As far as 2-point perspective is concerned, this is effective and simple enough to do. Going back to thirds, another popular measuring and dividing method is the special vanishing point method. Same rules apply. As long as this line coming off the corner of the square is parallel to the horizon, the corresponding horizon, which is important. It will become more important as the drawing has more horizon lines. So after placing this line can be placed intersecting this corner of the square, and then this space can be divided. The interesting thing here is that this space, or in other words, this intersection, this first intersection with the corner of a square, can be fairly random as long as it's not too far on this side of the square. And I will show examples of that. And again, for all of these tests, these intersections all the way along from this point to the vanishing point were checked, as well as the resulting lines from the vanishing point. So on this same picture line, this line that intersects this corner of the square has been placed farther, which brings this special vanishing point closer to the left vanishing point. But the spaces, or this square, is still divided evenly, even though now we have 4 spaces. And where these lines intersect this edge are the resulting receding lines converging to the left vanishing point. One final test for the special vanishing point. 5 equal spaces, and I think this one can speak for itself. So this is still in 2-point perspective, going back to dividing into thirds and back to the cornrows method, except this time, instead of this part of the picture plane intersecting with this corner of the square, the perspective square, I have placed this line at a random distance away from the square. And I think this is more practical, at least for traditional art. In digital it doesn't matter because these divisions can be made by the software. But in traditional art, it's a little easier to use something like a ruler, changing what part of the ruler you use, whether it's centimeters, inches, or whatever. You're more likely to find 3 equal measurements on the ruler that would align to these converging lines. Still limited because these lines will dictate a lot, but I think it's a little more practical. And again, all of these intersections land on the exact coordinates, so this method passes. Same kind of setup, this time in fourths, and taking some liberty with the distance of this picture line. But you can see these lines still intersect, which means these divisions are correct, even though this line has been placed much further away from the perspective square. One final example, fifths, and everything works here. And definitely this is a lot simpler than trying to get all of these diagonal lines, especially depending on the medium, the thickness of the line, and if it's freehand or not. This can have a high margin for error. So this should be a lot more practical. This is an example of placing a random diagonal between these barriers for a 2-point perspective setup. Because this vertical is perpendicular to the horizon line, these boundaries can be parallel to the horizon line or perpendicular to this vertical. Then any evenly spaced diagonal can be placed at any angle in these 2 lines. Then those spaces can be transposed into perspective and taken to the vanishing point. And they can be translated vertically on this side as well. Here's a simpler view of translating these horizontals vertically using this diagonal. Driving the point further, this vertical has been extended down, but the same concept has been applied. This side is divided into 4 even spaces and taken to this vanishing point. Then these intersections translate these horizontals vertically onto this plane. And again, as with all the other tests, the lines being divided outside of perspective and taken into perspective are matching up or intersecting with these diagonals. And based on our earlier tests, we know that these divisions will be even.